Let's watch some crazy stuff, yo!
Okay, so we got a geometry test coming up here shortly. Let's do some review problems and see if we're ready. Multiple choice in 1 through 6. Choose the best answer. So we've got circle C. Arc A to B is 62 degrees. What is the measure of the central angle, ACB? Well, central angle and the arc it intercepts are going to be the same. Answer is B. Number 2, in circle A, DBC, D to B to C, this is 38 degrees. We want to measure the arc DBC. Ooh, now we got to be careful. So we want this red arc here, and this inscribed angle, we would have to double it to find out what's going on out here. 38 times 2 is 76, and that's the part of the circle we don't want. So 360 minus 76 is 284. A circle has area, 289 pi centimeters squared. What is the approximate circumference? So let's be careful. We're going to have to use area equals pi r squared to find the radius. That radius is going to go into circumference equals 2 pi r. So back over here, we know our area is 289 pi, and that's equal to pi r squared. So immediately, we can divide out the pi. So r squared equals 289. And we would take the square root of that. R is equal to 17. And that is our first decoy answer. So if you solve and you got that, you think you might be done. No, we just found the radius. That radius is going to go right here. So the circumference is 2 times pi times 17, or that would be 34 times pi. And that is about 106.8, and that's option C. All right. Number 4, find the distance around the circle, so that's just a different way to say circumference, to the nearest foot. Circumference, we can use 2 pi r, or pi times diameter. Diameter is given as 21, so that's just going to be 21 times pi. That's about 65.97, and that's pretty darn close to 66. 5 through 8, use the figure at the right. It says, which of the following are chords? So here's P to Q. P to Q. Yeah, that's a chord. See, PV right here, that's a radius. UV, that is also a radius. And U to Q. U to Q is a diameter, but it's also a chord that goes through the center of the circle. So we got a couple answers there. Which arc represents a semicircle? Let me clear off my picture. I'll switch to blue ink. Let's see, PQ. Here's PQ. That's not halfway around the circle. U to P to S. Here's U, and we go to P, and then we go all the way around to S. No, that's way more than a semicircle. USQ. Here's U, and then we go to S, and then we go to Q. That's on opposite ends of this diameter. So USQ is a semicircle. What about PUQ? Well, here's P, and we'll go to U, and then we go to Q, and no, we've gone too far. So our only option there is C. 7, name a minor arc. There's going to be multiple answers. Let's just go through a few of them. P to U would be a minor arc. U to S would be a minor arc. S to Q would also be minor. And P to Q would also be a minor arc. So any of those are fine. A central angle, we have to go to the center and then out to 2 spots on the circle. So here's one in red. UVP would work. Or let's do PVU. I got that one in red. And then here's one in blue. That would be PVQ. Or you could write it in reverse. And I think that's it for central angles. All right. Number 9. I drew the picture here. It's not in your on your review. Kite ABCD is inscribed in circle P. So here's my center, my circle P. I got a circle. Vertices B and D are endpoints of a diameter. So here's B and here's D, endpoints of a diameter. And it's a kite. So I just connected here to here, made those the congruent sides. And then A to D and C to D to finish off the kite. The measure of BDC is 27. B to D to C, so this angle here is 27 degrees. What is the measure of arc BC in degrees? So here's arc BC in blue. If we go back to the inscribed angle here, it would be half of that arc. So let's double that, and it looks like we're going to get 54. Yes, arc BC equals 54. Yeah, and that would be degrees. All right. What is the measure of arc CD in degrees? Well, here's CD. Those two together, the blue and the red, would make half a circle. Half a circle is 180. We've already used up 54 degrees for BC, so the leftovers are 126 degrees, and that problem is done. Number 10. So in circle C, let me do this a little better. I'll do it over here. Inscribed angle DEF. So I'm going to put D here to E to F. The angle measures 4x plus 17. Arc DF, I'll hit this in red. Here's arc DF, is 9x plus 25. So there's a couple ways we can do this. I'm going to write them in black ink equal to each other. 4x plus 17 is equal to the 9x plus 25, but I know that's not right. So there's two ways to write the ship. I can either take this and cut it in half, so I could put a half out here in front of the 9x plus 25. The other option would be to double this side. And I think I'm going to go about it this way. Let's distribute the 2. So that's going to be an 8x plus 34 equals 9x plus 25. Let's minus 8x. 9x minus 8x is 1x. So I'm just going to throw this 9 in the garbage. So there's x, and I've got plus 25. Well, if we minus 25 here and 25 here, we're going to get x equals 9. X equals 34 minus 25. X is 9. Now, I almost thought I was done, but if we go back up and read the rest of the directions, what is the measure of angle DEF in degrees? Well, DEF is our angle right here, and that was 4 times x plus 17, and that 9 we just found is going to hop right in there. 4 times 9 plus 17 is 53 degrees. All right, we're on a roll. Number 11, use the circle at right to find each arc measure. Let's see what we've got listed here. This angle B to center to C is 52. We got a right angle here. Oops. So let's just see what they ask for first. E to D. E to D. So we're looking for this. Well, if this is a right angle, this is also a right angle. And we've got 52 degrees here. 90 minus 52 is 38. So angle, or ED, here is 38 degrees. Let's see, next it wants arc from E to A. Well, here's E, and we're going to go to A, and AD is a diameter, so we're going to do 180 minus 38. That should be 142 degrees. And then back to, I'll do black ink, measure of arc C to E to A. So here's C to E, and then we keep going to A. Well, let's see, we just figured out the arc I covered up that was blue was 142. ED we know as 38, and this 90-degree angle is going to give us a 90-degree arc out here. So for part C, if we add up 90 and 38 and 142, we get 270 degrees. Excellent. Number 12, a circular parachute has a radius of 12 feet. What is the approximate amount of fabric, or that would be the area of this circle? What is the amount of fabric that the parachute is made up of, nearest square foot? So good old area equals pi r squared. Area equals pi times 12 squared. 12 squared is 144. So we've got 144 pi would be the exact area. And if we punch it in the calculator, that is approximately 452.389 feet squared. But we were asked to round to the nearest square foot, so that 0.3 means we're going to round down about 452 square foot. All right, number 13. Diagram is given. Points E and F lie on circle P, dimensions shown. What is the exact arc length of EF in centimeters? Well, here's E to F. So that's part of our circumference. What fraction of the circle is it? It's 130 degrees out of a full 360-degree circle. And then we want the arc length, so let's use our circumference, 2 times pi times radius 42. When it does say exact, so we don't want to round off, exact means we'll probably leave that pi in there. So let's see, on our fraction we can drop the zeros. That's 13 over 36 times this 2, I'm going to write as 2 over 1. 42 is 42 over 1, and all of this is multiplied by pi. So if we just multiply everything straight across, so that would give us 1,092 over 36 pi. And that does reduce down, where'd that answer go? 91 pi over 3. Oh, and our units, I almost forgot units. Arc length would be linear. That would just be centimeters. Okay, and part B, what is the exact area of the shaded region? Well, the shaded region is opposite this 130. So 360 minus 130 leaves us 230. So in the shaded region, our percentage of the circle will be 230 over 360. And we're going to multiply that by pi radius squared. Radius is 42. So the 23 over 360, we can drop the zeros. So that's 23 over 36 times 42 squared is 1764 and times pi. So if we multiply our numerators together and divide by 36, it should come out to be a nice 1,127 pi. Our units here, area, would be centimeters squared. Okay, 13, done. 14. Area of a sector has this area, 514 pi centimeters squared. The arc that cuts it out is 160 degrees. What is the radius? So let's see here. Area or a sector of a circle, area equals, we have our x degrees over 360 times pi r squared. Area is given 514 pi. That's equal to our angle is 160 over 360. And then we have our pi, and then finally r squared. That's what we're solving for, is the r squared. So I would first divide out pi, divide out pi. Now on the left, we've got 514. I'm going to put that over 1. So to get r squared alone, we're going to multiply by the reciprocal of this. And I'm going to drop the zeros and then just turn it over. So now it's 36 over 16. So we can just multiply straight across there. And when we multiply across, our numerators will give us 18,504. And our denominator will be 16. So I'm going to divide that 18,504, divide that by 16. So r squared is about 1,156.5. And then I'm going to take the square root of that. And I get about 34.007. So I think 34 is good enough. We'll round it off to that. What is the radius of the circle? I think we got it. Okay, number 15, we've got some concentric circles shown. We did an example and a Huddle problem like this in class. The shaded region represents 36% of the total area of the outer circle that has a radius shown. Find the area of just the shaded region. So I'm going to write here whole for the whole circle. The area of this whole circle would be area equals pi times radius 58 squared. So 58 squared is 3,364, and that would get multiplied by pi. So the area is roughly 10,568.3 centimeters squared. So that's the area of the whole thing, and it said the shaded region represents 36% of that. So we want 36% of this, so we're just going to multiply that by 0.36. And that turns out to be 3,804.59 centimeters squared. All right, that was a little different than what we've seen in class, but it wasn't too bad. All right, maybe I don't want to erase these. Oh, well, the next one's pretty easy. Find the area of the non-shaded region. So we're going to take the whole area, the total area, and subtract what we just found. So it'll be the 10,568.3. We'll subtract the answer from above, 3804.59. The difference between those, 6,763.72 centimeters squared. And then finally, part C, find the radius of just the non-shaded area. This 58 radius went all the way to the end of the shaded area. So what we should do here, I guess I can just erase up here. I'll move up a little bit. Need a little more room. Radius of the non-shaded region. So we're going to take our answer from part B. That is 6,763.72, and that's going to equal the area, or the pi r squared, with our new radius. Again, that's going to be less than 58. So on our calculator, we're going to take this decimal, we're going to divide it by pi, and that will be r squared. R squared should be about 2152.96. And then to get just r, we're going to square root both sides. And what we should get is about 46.4, and that would be centimeters for our unit. All right, I hope you found the review helpful. Study up using this before we have the test. The test questions will be pretty similar, and I'll see you.